From a random sample of 48 days, in a recent year for a U.S. city, gasoline prices had a mean of $3.63. Assume the population standard deviation is 21 cents. Part A says, construct a 90% confidence interval for the population mean gasoline price, and then interpret the results. So n is equal to 48, x bar is 3.63, sigma is 0.21, c is 0.90. So if we use the z-interval command on the calculator, our confidence interval is 3.58 to 3.68. And this means that with 90% confidence, we can say that the true population mean gasoline price is between $3.58 and $3.68. Part B says, construct a 95% confidence interval for the population mean gasoline price, and then interpret the results. So all of our information is the same, except for C is now 0.95. So let's recalculate the z-interval. It's going to be 3.57 to 3.69. And this means, with 95% confidence, we can say that the true population mean gasoline price is between $3.57 and $3.69. C says, construct a 99% confidence interval for the population mean gasoline price, and then interpret the results. So again, all of our information is the same, except for C is now 0.99. So let's recalculate the z-interval, and it is now 3.55 to 3.71. So with 99% confidence, we can say that the true population mean gasoline price is between $3.55 and $3.71. D says, which confidence interval is the widest? So the 99% confidence interval is the widest because it has the biggest range. So it goes as low as 3.55 and as high as 3.71. So because we've increased the level of confidence, the interval needs to be wider to guarantee with 99% confidence that the mean is contained within it. And essentially this is like creating a larger target to give us a better chance to hit it.